So this is problem number 3 from the 2012 AB exam. It was also on the BC exam. It's a non-calculator question. And what they give you to work with here is this graph. And they tell you that f is the continuous function defined on the closed interval -4 to 3. This is the graph of f that we're provided with. We're told that it's consisting of 3 line segments in a semicircle centered at the origin. And then we're given this other function g defined to be equal to this, and that depends on the function f that we have the graph for. So find the values of g of 2 and g of -2 is what we're asked to do here in part A. Don't overthink this initially. If you're looking for a function value, in this case g of 2, you're putting 2 in place of this x and you're putting 2 in place of this x. So really all you have to do to find g of 2 is you have to find the value of this integral. Now since we have the graph of f provided to us over here, we're just going to need to do a little bit of work to figure out what the value of this is. And we can use graphical arguments for this, or we can actually do an integral to find the value of this. So I'm going to talk about it from a graphical standpoint using area arguments initially. I think that's probably the easiest way to approach this. So we have this triangle right here. A definite integral corresponds to a signed area. Since this area is below the x-axis entirely, the value of this integral, and hence g of 2, is going to be a negative value. If we can find the area of this triangle, we're going to have a pretty easy way to find the value of g of 2, or the value of that integral. So I'm just going to draw the triangle a little bit bigger here. And it's a right triangle. We know that this goes from 1 to 2 along the x-axis. So if we call this the base of our triangle, we know that it has a width of 1. And then if we call this the height right here, we are going to have to do some work to figure out what the height of this triangle is. And let's see, the height, if we think about where this y value right here, let me clean this up a little bit. If we think about where this y value right here on that line is, I think we can use rise over run to basically put that y value in place. To get from this point, which we know is on the graph of f, to this point, which we also know is on the graph of f, we'd have a rise of -1 and a run of +2. So if we have a rise of -1 and a run of +2, that would be a slope of 1/2. So the slope of -1/2, excuse me, the slope of this line is -1/2. So if we have a slope of -1/2 and we want our run to be 1 unit, so our run to get from the x value of 1 to the x value of 2 has to be a run of 1 using rise over run. What does our rise have to be if the value of this fraction has to be equivalent to the value of this fraction? Well, our rise is going to have to be -1/2. So what that tells us is that the y value right here on the graph of f has to be -1/2. Meaning the height of our triangle is 1/2, and the area of this triangle is going to be 1/2 times the base, which we said was 1 unit, times the height, which is a 1/2 unit. Do the math. 1/2 times 1 is 1/2. 1/2 times 1/2 is 1/4. Since this region is entirely below the x-axis right here, all we're going to have to do to state the value of this definite integral is make that 1/4 negative. So g of 2 is -1/4. To find g of -2, let's take a similar approach. So to find g of -2, we're just literally going to put -2 in place of the x in the function g. So that's going to be the definite integral from 1 up to -2 of f of t with respect to t. Now if you want a definite integral to compute signed area for you, you do need these limits of integration to be in the proper order, meaning the smaller number is going to have to be the lower limit of integration and the larger number is going to have to be the upper limit of integration. We don't have that going on here. We're always allowed to change the limits of integration, exchange them with each other, as long as we change the sign out in front of the integral. So I'm changing the sign out in front of the integral, flipping the limits of integration. Now I need to figure out what the value of this integral is. So let's see. If I'm going from the x value of 1, and let me get rid of what we were using for the first part of part A here. If I'm going from the x value of -2, so if I'm going from this x value to this x value at 1, Using signed area arguments, I can find the area of this triangle right here. That triangle is entirely above the x-axis, so the area of it would be positive within this definite integral. And then the area of this semicircle, which we would have to make negative because it's below the x-axis. So let's see, the area of this triangle first off, a little easier than the first triangle we dealt with. The width right here, or the base of this, is going to be 1 unit. It goes from -1 to -2 to -1 on the x-axis. And then the height, the y value that we get up to here at this point, is a y value of 3. So the area of this triangle right here is going to be 1/2 base times height. So that's going to be equal to 3/2. So the value of this integral is going to be 3/2, and then minus whatever the area of this semicircle turns out to be. Well, the area of a circle is pi r squared. The area of a semicircle is going to be 1/2 the area of the circle. So all we would need to do is figure out what our radius is. That's pretty easy to do. They told us in the problem statement that the circle is centered at the origin, and the radius of the circle extends, +1 this direction, +1 this direction, 1 this direction. So the radius of the circle is 1. So the area of this semicircle is going to be 1/2 pi times 1 squared, which is just 1/2 pi. So the area of that semicircle is 1/2 pi square units. We're going to make that value negative since that region is below the x-axis and a definite integral computes signed area. Now the only other thing that I have to account for here is the fact that I had this negative out in front of my integral to switch the limits of integration. And if I want, I guess I can clean this up a little bit. I can distribute my negative in, and my result will be -3/2 plus 1/2 pi, or plus pi over 2 for the value of g of -2.